Hello everyone. So let's now solve practice assignment week 5 question number 1. Let A and B be square matrices of order 2. Which of the following option is true? So let's look at each option one by one. So we have given that in option nullity of AB is equal to nullity of A plus nullity of B. So let's take two matrices A and B to be this matrix. Now if we check, A has only one pivot element and it's at order of 2 cross 2 matrix. So the rank of A is 1 and the nullity of A would be 1 as there's one independent variable. Similarly, nullity of B is also equal to 1. So nullity of A is equal to 1 and nullity of B is also equal to 1. Now if we do the product of these two matrices and we get the AB, we get this matrix, and this matrix is same as B matrix. So nullity of AB is also equal to 1. But in the option it is given that for any two square matrices of order 2, nullity of AB should be equal to nullity of A plus nullity of B. That is not the case here. That nullity of AB is not equal to nullity of A plus nullity of B. Hence option 1 is incorrect. Now let's look at option 2. So option 2, that nullity of AB is equal to nullity of A times nullity of B. So now let's look at A matrix to be our this matrix and B to be this matrix. So again nullity of A is 1 as there's only one pivot element. So the rank would be 1 and nullity would be 1. And same here also, if we try to reduce this matrix by interchanging these two rows, then we will get only one pivot element and hence rank would be 1 and nullity would also be 1. So nullity of A equal to nullity of B equal to 1. And if we try to find AB matrix, that would be 0 matrix. So here nullity would be 2 as there's no pivot element, and in other words there's two independent variable. So nullity of AB is equal to 2. And our option says nullity of AB should be equal to nullity of A times nullity of B. That is not the case here. Hence option 2 is also incorrect. So what we are basically doing here is instead of trying to prove this statement, we are trying to disapprove this statement by taking some counter examples. So that's what we are going to do for the option 3 also, that nullity of A minus B equal to nullity of A minus nullity of B. The best way to disapprove any statement in mathematics is to just find one counter example for that statement. Now option 3. So for this, let's take our A matrix and our B matrix to be this. So nullity of B is easily visible that it is 1. And if we talk about the nullity of A, we can try finding the determinant of matrix A, and that comes out to be 4 minus 6 equal to -2. And because determinant is non-zero, the nullity would be 0 for matrix A. So nullity of A is equal to 0 and nullity of B is equal to 1. So in the option they want A minus B. So if we do A minus B, what we will get is 1, 2, 0 and 0. And the nullity of A minus B is equal to 1. And the option says nullity of A minus B equal to nullity of A minus nullity of B. But that is not case here, as nullity of A minus nullity of B is equal to minus 1. That is not equal to nullity of A minus B. Now let's look at fourth option. Rank of A plus B equal to rank of A plus rank of B. So let's take example for our matrix A to be this and B to be nothing but just the negative of A. Now, if as we can see that the first and second row is same, so when we are trying to reduce this matrix, the second row would become 0 and we will get only one pivot element. So the rank of A would be 1. And similarly, the rank of B would also be equal to 1. And if we talk about our A plus B matrix, as B is nothing but the negative times A, so A plus B would be 0 matrix. And the rank of A plus B would be equal to 0. And that is not equal to rank of A plus rank of B. Hence, option 4 is also incorrect. And as none of the above options are correct, so option 5 would be correct. So let's now solve question number 3. Which of the following options are true? For checking the correctness of these options, we will be using rank nullity theorem that says for any m cross n matrix A, rank of A plus nullity of A is equal to n. So let's look at each option one by one. So option 1 says if A is a 2 cross 3 matrix, which is a non-zero matrix, then the nullity of the matrix is less than equal to 2. So this means we have to check the maximum possible nullity. And to check, we have to find the minimum possible rank. So A is a 2 cross 3 matrix. So from rank nullity theorem, we have rank of A plus nullity of A is equal to 3, that is the number of column. We have to find the maximum nullity. For that, we should have the minimum rank. So minimum possible rank in general case it is 0, but because it is already given that A is a non-zero matrix, so 0 rank is only possible in the case when our matrix is 0. But as it is already given that A is a non-zero matrix, so minimum possible rank of A is at least 1. The rank of A should be at least 1. So with that we can find the maximum possible nullity, that is at most 2. So that's why we get the nullity of A can be at most 2. Now let's look at option 2. If A is a 3 cross 2 matrix, it is a non-zero matrix, then the nullity of matrix A is less than equal to 1. So it's the same type of question, it's just that the order of the matrix is different, but the procedure would be same. That from rank nullity theorem, rank of A plus nullity of A is equal to 2. And again, A is a non-zero matrix, so minimum possible rank would be 1. And when we have minimum possible rank, so the maximum nullity that can happen is also 1. Now let's look at option 3 and 4. So option 3 says let A and B be two square matrices of order 3. If nullity of the matrix AB is 0, then the nullity of A is also 0. While option 4 says that let A and B be two square matrices of order 3. If nullity of matrix AB is 0, then nullity of B is also 0. So let's check. We have given that A and B are two matrices of order 3. So as they are square matrices, so their product could also be a 3 cross 3 matrix. And the nullity of AB is given as 0. So this implies that the determinant of AB is not equal to 0 as it is a square matrix. So we can find the determinant. And because nullity is 0, that means determinant should not be equal to 0. So we know from the property of determinant that determinant of AB is equal to determinant of A times determinant of B, and that should not be equal to 0. And as determinant is a real number, so that means from here we get that determinant of A should also not be equal to 0 and determinant of B should also not be equal to 0. Only then when these two conditions satisfied, this condition can be satisfied. And because determinant of A is not equal to 0, so as A is a square matrix also, we get the nullity of A to be equal to 0 and same as nullity of B to be equal to 0. So that means both the options are correct. So all options for this questions are correct. Thank you.